In this problem, we have a pro golfer that hits a golf ball 126 yards for a hole-in-one. The duration of the golf ball's flight was measured to be 5.6 seconds. Determine the initial speed of the ball and the angle theta at which it was struck. Alright, so this is a projectile problem, because once the golfer hits the golf ball, it's flying through the air without any additional force added to it. The only forces acting on it would be the weight force. We're going to neglect air resistance in this case. So what we have is the golf ball travels a distance of 126 yards, and it takes 5.6 seconds. All right, so how are we going to attack this problem? Well, with projectile problems, it's always good to label important points. So an important point would be at the beginning, at the end, and at the apex of travel. So we're going to label those points so that we can reference to them. And in projectile problems, I always like to start in the x direction. This direction is really the easiest to work with. It's only got one equation. We can usually find a missing value or have an equation that we can use later. All right, then once we do the x direction, we'll analyze the y direction. All right, so here's the figure. I've labeled the points, the beginning point, end point, and the apex. I've also put a coordinate system, because if we're going to talk about the x and y directions, we need to indicate that on the figure. All right, so for the x direction, we have this equation for the range or the position in the x. The acceleration in the x is 0, so that means that the x velocity is constant. We're going to take this equation and apply it at point C. So the x position in point C is d, and the x velocity is v naught cosine theta. All right, we project it onto the x-axis. And the time it takes to get to point C is t sub c. All right, well, we don't have everything we need to solve for one variable, right? We know d, we know tc, but we don't know theta, and we don't know v naught. So we'll just label that equation 1 and go on to the y direction. All right, so for the y direction, we have a position equation that we can use. We're going to apply that at point C. So it starts and ends at a position of 0. This is the y direction velocity, sine theta. It takes tc, time tc to get there. And so we label this equation 2, because again, we don't know enough to solve for v naught and theta in this equation. All right, so we have two equations, equation 1 and equation 2. What I'm going to do, and what is the easiest to do, is divide equation 2 by equation 1. In this way, we can get rid of v naught, and all we're left with is theta as an unknown. So we can solve for theta very easily because we know d and we know tc. So once we solve for theta, we can plug it back into either equation 1 or equation 2 and find what v naught is.